Okay, folks. Anyone awake? Well, I mean, I can have one of two possibilities here. I mean, maybe my real purpose is to put everyone to sleep after lunch. You know, you get the nice snooze before. Okay. Anyway, how many people here use object-oriented programming in Perl? Oops. Bad jokes aside. Okay. If you think back a long time ago, in the dim and distant past, it was Damien's object-oriented programming book that first led a lot of people to treat object-oriented Perl seriously. And we've come a long way since then. But you notice a lot of the things that he suggested way back still work. What's interesting about the OO in Perl is it's really been a process of evolution. It's adapted over time to new additions, which is why a lot of old stuff still works. And that evolution has allowed us to layer pieces of it on top of other pieces. I mean, some of it may look a little rickety, but there's an enormous amount of flexibility in it that you don't have in other object languages. And a good example of that is Next. How many people use this module? Know what it does? This is one of the first things that made Damien famous. Everyone here use super? If you want to redispatch to another? What's the problem with super, people? If you call super and there isn't a next method, it pukes because there's no next method to dispatch into. So what next did is next redispatches if there is something and just politely returns if there isn't. And that made it very easy to stack things because if you were the last one on the stack, you didn't care. Now, another great thing that was added, that was part of the next module, which actually makes next usually extraneous, were two pseudo-classes, every and every last. Anyone here use those? Oh man, your lives are just about to get much easier. If you're using super or next to daisy chain, usually in construction, the initializers, and when you're destroying things, the cleanup, you have to explicitly call it. Quick, everyone think, if you're in an initializer and you want to call super, do you call it at the start or at the end? Well, it's easy to mess that up. So what every says is if I have an object and I call every foo on it, it will go from the most derived down to the least derived class, and it will dispatch foo for each of them. Every last goes from the bottom up. So what happens is if you're initializing things, you want to go from the least derived to the most derived class. So the least ones get, the most basic structure, and then you add on to it. This is a generic new. You will never have to replace it, ever. And none of these initializers have to daisy chain. What happens is every last initialize is a pseudo-class that iterates finding initialize where it exists and calling it. Destroys do the other. They call every cleanup. You can write one base class and never change it, because the initialization and the teardown are all handled for you. Now, one bit of evolution in Perl's OO is the addition of MRO. Do people use MRO? DFS, C3. The original mechanism for finding a method was to do a depth-first search. Your class derived from left first, so it would go down the left to the bottom, and then it would go down the middle to the bottom. The problem with that is you get a lot of surprises because you might have a more derived class that defines something, and you don't call it because it's further to the right. The other reason that it can be confusing is that depth-first search, because it calls it in order by the inc variable, by the order of inheritance. If you modify that, if you change the order you use two parents in, you can completely change how everything works, which is not always pleasing when somebody else changes their module and breaks everything because they changed the order and you didn't know about it. Now, MRO doesn't have every and every last. It has a thing called maybe next, which maybe next is a lot like next. It says, look, if there is another method, call it. If there isn't, don't. But it means I have to hardwire it. Can anyone tell me what's wrong with this? Initializers have to dispatch first so that less derived classes can handle the basic construction before the more derived classes. This is done backwards. The ... dots had to be below the maybe next. This is why using maybe next is a bad idea. It is too easy to screw it up or leave it out and you get a half initialized object, which is why I like every and every last. So there's one quick fix. Basic attribute of a Perl programmer. Let's go fix it. What I want to do is hack MRO. Now, again, what MRO did is it added, along with depth first search, a method search called C3. There's some academic stuff on it, but basically what it guarantees is you will never call a more base class before one derived from it. So instead of depth first, where you call all the way down to the bottom and then you go down, this one goes across from the top. So it looks at the most derived, the next most derived. It goes tier by tier down looking for things. If you use that for a constructor, it means calling every last with a C3 approach. You will call all the most base, the leaf nodes, before you go up one tier. So the trick then is, how do I dispatch this? So it's going to look like next. We're going to have to call MRO every. And then you're going to call, let's say, your Frobnicate class. You'll construct something, and you call every last initialize. Now, what's fun about that when you write a pseudo-class like this, how is it that I can redispatch a subroutine whose name I don't know and I can't control? Anybody? Autoloads. COBOL lives. No, it's true that autoload was taken from COBOL because it used to be that on the old mainframes you had so little memory that you had libraries that didn't fit, and if you couldn't fit something, you would load it into memory. That's where the thing came from. So with an autoload, what I can do is I can take any subroutine whose name I don't know, and I can say, that's where I want to be. And one of the things that Damien made a big point of in Perl best practices was don't use autoloads. And of course, half his stuff uses autoloads. So the trick here is MRO has a function called getLinearIsa. And if you're in DFS, depth first search mode, it will give you the left tree the way you expect. If you're in C3 mode, it'll give you the flattened out version that calls the more derived things first. So I can always get a list of where do I need to look for whatever this method is. So if people haven't seen autoloads before, I guess this is an explanation of how this works. You're going to call every bar. And what I have to do is I've got a package called every. Okay, but there's no bar in it. So Perl says, do you have an autoload? You do have an autoload. I will dispatch there. What it tells me, though, is there's an autoload variable that will have the name of the thing that was being dispatched, which is how I can tell what I should be doing. From here, I can take the autoload, I can strip off the last word, because we know that subroutines in Perl are words. So that takes care of all the double colons, all of anything else. This is a little bit more work in Reiku, where it might be an atomic sign for all you know, but Perl is easy, it's words. From here, I've got the name. I can grab, Oh, yeah, good point. So much for writing this in the middle of the night. Thank you. So I take the autoload, I get the name off of it, or I can do a split on double colons -1. At that point, I got a prototype, because I don't know if foo is a class name or it's an object at this point. I don't care. So now I can say, get me the linear ISA, and that @* is newer Perl. It says, take this list and flatten it out. So it's sort of an object notation for the whole array. This gives me a list of every place that I'd have to look to find this package, the foo package, actually doing whatever I asked, the foo in this case. So the most common way to look, people say, oh yeah, this is easy, you use package to can. Do you know why this doesn't work in this particular case? Inheritance. It's all in the genes. Yes, the problem here is I'm going to find every place that you inherit it, and I only want to go to the places that declare that they actually can do this. There are two ways to do this. I'll show you the other way later. But to dodge the inheritance, the simplest way is symbol. People use that module? This makes it really easy. This module makes it blindingly easy to do introspection with Perl. So basically what I'm going to say is, qualified ref generates a glob in a package. It generates a reference to the glob in the table at that point. So I can then ask, hey, is there code in that glob? If there is, you define it. I can go there. Does this make sense to people? Symbol makes things enormously easier. If you're writing stuff that has to export, you can find your caller space, you can install anything you want. If you have to wrap a subroutine, you can find the subroutine you're wrapping and install it. Being able to generate references or qualify things without having to use no strict, just to be able to put the double colons between things and get them right. This method makes, the module makes things much easier. But what this asks the question is there something with that name in that package that is code? If that's false, skip it. Otherwise, I got a subroutine and I can dispatch it. This will do, so I'm going down the tree. So this is every. This will take every occurrence of something being defined and it will run it. I'll show you there's a slight problem with it, but it's a good first approximation. You can see how this works. And again, if this is in a constructor, the nice thing is if the name is initialize, none of these initializers have to know about any of the others. None of them have to call the next one. None of them have to trap the next one not being there. None of them have to worry about whether they're first or last or whatever. They just get called with the arguments. They do what they're supposed to. One thing this doesn't handle is autoloads. If you use an autoload to manage whatever it is you're calling, there's a bit more magic I'll show you in a minute. Now, if you dispatch up the tree, then you're looking at every last, which just reverses the order. That's going to call the most base classes. It's going to work its way up. If you do depth first search, it's going to go down the left side, find all of these, and then up down each fan. If you have single inheritance the whole way up, there's really only one way to do this. But with multiple inheritance, C3 gives you a much saner approach. Whatever you've chosen, I'm going to get your ISA, and I'll dispatch to each one of these, every place it's defined. Now, one thing though you notice, one of MJD's famous things in the Perl journal was red flags, avoiding red flags. One of the biggest red flags is cut and paste. If I've got two autoloads, the only difference between two subs is the word reverse in one of them, I'm not doing it right. So one of the things I can do is create a little anonymous sub that finds the list. And that's just the get linear ISA. This will find me all the places and it'll get me a list of subrefs that I can dispatch. At that point, every just looks at whatever methodology returns, and I just reverse that. Now, anyone that's still awake after lunch noticed that there's a unique floating around in here. Anyone know why this is here? If multiple classes use a module and that module inserts something, I don't want to call the same function multiple times with the same object. By calling unique, and this is one of the things I pointed out in my last thing, unique returns its unique list in the order of the inputs. If I had tried to unique that with a hash, I would get a random order, which is probably not what I want here. So unique will give me the, going down the classes, it will give me the single most derived instance of each part of the tree that defines that method. If it's inherited by use from the same other module installing it, I'll get the most derived one first. If I'm going up the tree with every last, I will get the least derived copy. Even if 5 of them have it installed from the same place, I'm only going to do it once. So this gives you pretty good protection from over-initializing things where you know, if you have to double a number, it comes out 4 times. I'm only going to call whatever there is where it's first defined. Does that make sense to people? Yes. Yeah, basically it's comparing the address. Because they all say sub on them, so it's going to be, and then the addresses are unique. And that's why it catches the install. Because if you do use croak or some, use carp, as many times as you install croak, it's a reference to the same anonymous subref. It's the same symbol. So I'm only going to find that code ref once. The trick is by using unique, if it's installed 5 times, with every, it's going to bump into the first one going this way. With every last, it's going to go into the first one going up. So I'm going to get it in the correct direction. That's why I have to do the unique after I do the reverse. And I couldn't put the unique in methodology. So yeah, this is what I just described. So looking down the tree, again, every is for writing destructors. If you have to disconnect the database before you delete the structure, before you do something, you would normally use every in a destructor, every cleanup or something, or they call that sub. And initializers use every last initialize, whatever you want to call your builder upper. Now, what if you have an autoload? You might use an autoload to handle some of this stuff. Maybe you have initialize or construct or something else, and they're all packaged in one way because it behaves a little bit differently depending on what you call it. There, I can't look up the name because the name is an autoload. The name is initialized, or the name is connect to the database or whatever. So what I have to do is a little bit more work. There's an alternate. If you don't have code out there, I have to ask, what else can I do to figure out if you can do it? And it turns out that we're back at can. So I need some help. Your class would end up saying, oh, I have an autoload, and here's my autoload, and here are the names of the things that my autoload can correctly handle. Initialize, deinitialize, construct, connect, whatever. You can then map those onto something that looks can-ish. It returns a subref if you give it the name. At that point, you can have a can that says either my object can, the normal lookup, or my autoload can do this. Does that make sense? If you do that much work, then I can do, here's another use for qualified ref. The other way to check is something can do it without inheritance. Did anyone here use local? People know what it means? So I've assigned a local value to the ISA. It's not a new variable, it's just a local value. It's empty. Qualified ref ISA in that particular class gives me a glob that I can assign an anonymous ref to. Bingo. You now inherit for the next couple of lines, you inherit from nobody. Now if I ask if you can name it, I'm only asking your one class because you have no inheritance. Local is a really neat thing. It's amazing how most languages don't have it, and it's surprising how many times you can use it. So basically at this point, if I can do the name, now notice I don't return can the name, I return the name itself. I have to dispatch to an AUTOLOAD by name so that Perl takes over, finds that the name isn't defined, and loads the AUTOLOAD variable for me. If I tried to dispatch this by subref, you'd get into the AUTOLOAD, but it wouldn't have an AUTOLOAD variable populated with anything. These will be online, I promise. They're not that beautiful. So again, if you can name, I have to return the name because I have to dispatch this by name. I can't dispatch it as a subref because there's a little extra overhead in the way Perl sets it all up. So now I've got this module, it's on CPAN called MRO every, and it's a pair of AUTOLOAD and a couple of maps. One that does the find without an AUTOLOAD and one that does the find with. I think it's something like, it's like 30 something lines of code. And that's only because I use Berkeley braces. I mean, it's short. And it doesn't take much to get this done. And I think it saves a lot of work when you're constructing things. And this is Perl, of course. There's another way to do it. Lots of hubris. Anyone here ever worked on Damien Conway's code? It's an interesting experience. I would say his stuff is amazingly clean and precise and uncommented. So it's a matter of having to go through and he's good. He's one of those people that's internalized these algorithms. He doesn't have to stop and think about how to get there from here. To him, it's obvious. The rest of us, however, now what happens is I replace his method lookups with MRO. Isn't that hard? Another thing is he wrote next before scalar util was written. So he uses ref instead of blessed to figure out if something is dispatchable by class. He assumes any ref that makes it that far has to be blessed. He's got no strict, and then he gloms together things with dollars and double colons. I could leave strict turned on and use qualified or ref to get to it. So there are a lot of cleanups in that module that he would love to see done to it. But no one's bothered. So there's one thing he has that's called ancestors and one called ordered ancestors. It's kind of a funny thing. If you use the next pseudo method, next uses ancestors that's depth first search. If you use the every and these are pure Perl. Sorry, I got ahead of myself. So this is a depth first search for a method in pure Perl. And it's not something I want to read at 3 in the morning. This is what it looks like using MRO. Not bad. And I can convert that to object syntax. So it's pretty much a one-liner aside from unwrapping the variable. This is what ordered ancestors look like. And this is where he's got the no strict refs and he's got to hack the ISA and he pushes. It's a mess. So again, I could replace all of that with get linear ISA C3. And we're done. Now, his ordered ancestors in C3 are just a little bit different, but they always constrain it so that more derived classes appear before less derived ones. So I have to do next and I have to do every and every last using different MRO lookups. Nobody noticed this for the longest, when they actually used the next module, because people weren't used to using MRO and they didn't think of it. The problem we get is there are a lot of people who, if I dispatch using whatever MRO thinks your module is supposed to use, there are people who are used to it being hardwired to the one or the other case. So to make it backwards compatible, I've got to be able to flag something. This is the way I did it. If you tell me backwards, then the next will have to store your class as doing it the old way for backwards compatibility. At that point, ancestors looks like this. So if you're doing it backwards, you've got to use depth first search. Otherwise, you use what's there. And the ordered ancestors is the same thing. Now, I've gone through all of this, and people are thinking, but wait, this thing was written in Perl 5.8.8. We can never change it again because Perl hasn't advanced since 5.8.8, right? Well, there is a way around this. The trick here is if you're running 5.8.8, you're stuck on Red Hat version 6, which companies still are, you're going to get 5.8. As long as you get one that's compatible with your version of Perl, you don't care if somebody else gets a later version. You're going to get what you need. So this is a trick I came up with in Find Bin Lives when it was written in 5.10 period. And I wanted to update it. And every time I updated it, people said, but you can't do that. It breaks my 5.8 installation. So what I have is a file tree of Perl versions. And when my makefile.pl gets run, it says, oh, you're running Perl this. It does a Schwartzian transformish thing with the version number and finds the greatest number that's less than or equal to your running version. And then it does file copy recursive to dump the lib and the t and the doc and the whatever directories, just copies them into the top level and keeps going. At that point, you install a version of the module that's appropriate for your version of Perl, and we're done with it. That way, I can have next, and I actually can update it to use probably 5.24 because it's got most of the modern features in it. And the people on 5.8.8 just live with it. If there's some of it that I update to 5.12 for people running on, Red Hat version 7, they can have their version too. So this approach would work for next. And yeah, at that point, there is more than one way to do things. By adding this as sort of a role to MRO, I can make it so that MRO will have every and every last without modifying MRO. So I can evolve it that way. I can go into next, and I can add this to next without interfering with the people who rely on 5.8.8. It's still perfectly doable to release it if they'll let me. So the advancing it's perfectly doable. And again, it's a neat thing about the OO and Perl because a lot of it is layered. It's very adaptable, and we can keep improving it. And with that, there's some references in here if anyone really wants to read them. This will be online. You can look and find bin libs on Meta CPAN. You can see how the makefile.pl does this. There's one thing I started work on, if anyone would be willing to help me with it. It's called Module from Perlver, which standardized that trick of having version releases and subders. And you could just go into your makefile and say use module from Perlver. And that's the only change you'd make. And then it would know how to deal with the version directory. And the problem with that is I didn't have every version of Perl ever built with every version of xutils makemaker installed on it. I couldn't do a Cartesian product of checking that all the syntax, that everything everywhere in my file worked with every version of makemaker that ever existed. So if anyone would ever be willing to help me with that, I think we'd be doing everyone a big favor. Because a lot of these modules that have been tied to 5.8 forever could advance. And that was about it. Any questions? Everyone with a heartbeat, raise your hand. Okay, he has to be awake because he's working the AV box. So if people are breathing, hopefully they got a nice enough nap after lunch. If not, Any questions? Gee, I kept you that excited, huh? We got a question. Well, actually, I'll show you the piece of next where I stole it from. Is it? Oh. Oh, well. Yeah, I can show. Look, here it is. The point here is the @isa array is who you inherit from. So far, so good? So let's say you use parent exporter. That means that @isa in your class is going to be equal to exporter. So far, so good? Now what happens? The symbol module includes qualified ref. I give it a name and I give it a package. So qualified ref isa, in this case $_, taken from, I got a pointer here, that was taken from this get linear isa. So this is going to be passing down in here. It's going to say, okay, this is the name of a package. In this package, does that name exist as code? If it does, take it. Done. If that's false, there's no sub there. Let's ask this. If I qualify to ref the isa variable, remember in Perl, isa isn't necessarily an array or a hash or a scalar or a file handle. It's a name that has slots for string and number and array and hash or whatever. So qualified to ref isa in that class is just giving me a glob. I can look in that glob for anything I want. In this case, by assigning it, by assigning it at array ref, I'm going to jam load an empty array into the current value of isa. I'm not replacing the variable. I'm localizing the value that that variable represents to me. So far, so good? But I don't want to screw up the class, so I'm going to make it local. What local says is that value is only seen in that variable for this lexical scope. So the curly brace down here, right there, right here at this curly brace, the value that I assigned goes away and the old value is now visible. I'm not affecting the global variable, I'm installing a temporary value into it. You can think of all the global variables in Perl really as a stack. And then local is just pushing new values onto it. Reiku makes this a bit more explicit. There are all these phasers you can attach to subs for entry, exit, once, last, all kinds of stages of things. So you could do that with a phaser in Reiku. Here we do it with local. But now, by assigning empty to isa, if I call that class's can name, I'm only looking in that one class. It can't inherit from anything because I've zeroed out its isa array. So now I can say can $name. I don't do that. I check the code because it's faster. It's a lot faster to just look in the glob and snag the value because then I get the subref the first time. Where this way, if I have to localize that value, assign it, that involves constructing an anonymous array, going in there, putting stacks, and I'm doing all that work just to find out that it does or doesn't exist. But if it can do that name, at this point, I've got the name. The wonderful thing about Perl is if I have an object points to a variable, that variable can have a subref and I'll dispatch to it, or it can have the name of something and I'll do the normal method resolution. So this will handle both. Did that answer your question? What did, right. Well, the difference is, if I find the code in your package, I can call object points to $sub, and I can dispatch into that sub, and I'm going to the right place. If I dispatch directly into an AUTOLOAD, I'm bypassing Perl's extra step of loading the AUTOLOAD variable in that package with the method that was being dispatched. And I'm going to get into that AUTOLOAD, and its first line is always going to be split up a regex the AUTOLOAD variable for the name of the subroutine that I'm supposed to be taking out. And it's not going to be there. So if I'm going to dispatch into an AUTOLOAD, I have to do it by name so that Perl says, oh, that isn't defined. You must want to go to the AUTOLOAD. Oh, I'm going to load the AUTOLOAD variable, and then I'm going to redispatch into the AUTOLOAD sub. The other thing is that the AUTOLOAD dispatch behaves a little bit more like a go-to. So yeah, it's a little, that's, you see, I could have had this as qualified ref name of code or AUTOLOAD of code. And I could have gone directly to the AUTOLOAD. But then I'd have to know I was going to an AUTOLOAD, and I'd have to jam load the AUTOLOAD variable myself. This way, if it's code, I just go to it. And if it's AUTOLOAD, I fail to find it and then go through the normal AUTOLOAD life cycle. Did that answer your question? Well, the difference is if I know that the sub is there, I can dispatch it by subref. If I know that it's an AUTOLOAD that's handling it, I have to dispatch it by name because Perl does some extra work to set it up so that that AUTOLOAD can execute properly. And I have to leave Perl to do its AUTOLOAD setup for itself. And the only way to do that is dispatch it by name, let it fail, and roll over the AUTOLOAD. It doesn't, it's not inheritance checking. All this does is it isolates the package to having no ancestors for the duration of that can call. Yeah, the only reason for doing that is I can use can $name. The point to using can is if you want the AUTOLOAD to work, you've overloaded your can operator to return true for the things that your AUTOLOAD can successfully handle. And by overloading can, I know that I can go there and get this done, and it's not going to blow up. Of the name of the sub that the AUTOLOAD will be dispatching. Oh, because what will happen is I'm going to call object points to $sub. $sub is going to be foo. Perl is going to go to that package. It's going to look at the point in, well, there's a, well, okay, the question about where does it get the $_ is a package. Oops, I hate that. Hang on, I'm sorry. $_ here is a package. I know that if I isolate the inheritance, no, I get the name. I'm dispatching it by an object. Down here, I know something. I asked this prototype, show me all the packages that make up your inheritance. Right. But what will happen is, the way AUTOLOADs work in Perl, if I call, well, it'll find some AUTOLOAD. At that point, it will find the AUTOLOAD in the inheritance tree that's there that says it can handle this. But you've already, the point to this was, if you're going to make it work, you've gone into your package and you've overloaded your can operator to return true for the things that your AUTOLOAD is designed to successfully handle. I'd actually get more than one of them, and what'll happen is if different AUTOLOADs handle different things, the way AUTOLOADs have to be written is that if you get something you can't handle, you then redispatch it to the next AUTOLOAD. if you're going to write things that use autoloads, and you're going to do it in an inherited situation, your autoload at this level has to be able to dispatch down the tree. Otherwise, your autoload wasn't written properly. 9 times out of 10, the only reason to use an autoload in any of this is your most base class has the use of an autoload here. Let's just say you've got a translation object, and it's got to load the dictionary from hell for every language that it sees. And you have a method for each language. I would call translator points to Russian or whatever, RU, whatever the language designator is, and a phrase. I'm going to bump into that autoload, and there's usually only going to be one autoload in the inheritance. And it's going to say, oh, it's time to go through the overhead of loading the Russian translation dictionary or making the connection to the Russian translation engine or whatever. And that's expensive enough that I don't want to do it for every freaking language that I know about at startup time. So it's the only reason for an autoload is you're amortizing the cost of doing something over runtime rather than startup time. The original use was in COBOL on mainframes when you couldn't fit the library into memory, and you actually had to push something out to push something in. Autoloads existed before demand paging. For the most part, PDPs made, and VMS made autoloads extraneous. Another use of autoloads actually is Object Trampoline, if you've ever seen that. It's a bunch of nested autoloads that allow you to not create an object but still have it when you need it. It's different from lazy initialization in that you don't actually have the object you want until you need it. The object morphs over its life cycle. But once it changes, you never go back because it actually is the original object. That's a fun talk. But yes, I didn't describe all of the autoload, but one of the things the autoload has to do at this point is if what it gets isn't what it needs, it has to call that again. Usually by calling a less derived class. You find your first ancestor and you call that ancestor points to autoload with the argument, and it keeps going down the tree. I can't avoid that. The only other way to do it technically would be to grab that autoload and then grab it as a subref. But then I'd have to have something that says if what I have is an autoload, then I have to jam load the autoload variable and I have to do a goto rather than a redispatching. So 601. Big autoloads are messy. Did that answer your question? Any other questions? That actually got done on time. Hey, Todd will be happy with you. These slides will be on presenter deck, I guess sometime today once I put that tilde back in where I missed it. What? Qualified a ref dollar name of code? Yeah. LAOD. Good point. That's why I usually line things up, because then at least I can spot them. Thank you for noticing. Yeah, I got to go through and recheck all of it. It's the fun thing about hacking these on the fly. What is? Where? Oh yeah, that's LibreOffice. I can't stop it. Yeah, There, that's better. Oh, shit. If I don't, God damn it. And that's the problem with that's the problem with progressive slides. You have to fix everything more than once. I mean, you tell me. I think the progressive slides help because you can start to see how the thing. But yeah, it's after you've duplicated the slide 18 times, you find the typo. You got to fix it that many times. And I've got to get that tilde stuffed up there. What the hell was that? Yeah. See, that is how I usually break them up. I could have split it on non-words, which would have done the same thing. But if you split it on double colon, the person that comes after me, which might be me, is most likely to realize that was doing it to split up a package. It's similar to the trick of, God damn it, where is that bloody AUTOLOAD? Yeah, it's somewhere up here. Yeah, the every last. I don't use every that often because destructors don't usually have that much brains in them. But the every last initialize makes writing, here it is, makes writing constructors, just new, never changes. My object equals ampersand construct. Object points to every last initialize and underscore object. And you're done. No one, it never has to change. You might want to hack your constructor if you want to return a hash or an array or a reference to a scalar or whatever makes you happy. But whatever construct is, new just gets one and calls every last initialize goodbye. And if you want to change the name of initialize, you can have $initialize in it. You pass that in as something at use time. But it makes a lot of the stuff blindingly easier. Especially if I've been in situations where we had connections to services that were finicky about being just cut off. You had to handshake your exit. And calling every cleanup and being able to take the class for a SIP servers was particularly nasty about that. For SIP or database or whatever, and explicitly call DBI to close or deconstruct that object. And just know that it was done without having to worry about everyone calling the next destroyer in the list. It saved me more time than I want to think about. Because then all of those things they don't have to worry about, do I call this at the beginning? Do I call it at the end? It just they get called one by one and they're done with it. And the unique avoids double deconstructing something because you inherited the same thing from the same place many times. If you have to, I guess I should have put that in here. If you have a class, and let's say you use DBI, and you have to call disconnect, but you've got multiple classes that all have to disconnect, you can always pick a name that isn't cleanup, that isn't in the module, and then each of the classes can call their own cleanup, can do whatever they need to whatever it is. But then they just map it to their own name called cleanup or deconstruct or whatever you find is a nice pretty word. So long as it isn't whatever that thing is exporting, everyone can wrap that, call it, and you'll all get called as many times as you need, even if it's exported from a module. Thank you for noticing that, whoever did. I probably never would have. Let's see. Save it. Exit LibreOffice. By Jove. Now, thank you. Let's see if this works. Bingo! 2 things in a row worked. I better quit while I'm ahead.